Hey, welcome back. So it's been a little bit. If you've been wondering where the hell I've been, I don't blame you. I've been working and waiting for things to stop sucking. A couple things really suck. One is New York State. The other is United States Postal Service. Let's just get that out of the way real quick. So I finally got my regulators, the higher flowing regulators. Um, and that's basically where the two items that suck are coming from. Nobody local would sell me one. They didn't even want to try. Basically, they're all afraid of the big L word, liability. So, because you're not a professional installer, and apparently have the IQ of a rock, they won't even sell you the thing. So you got to be a business. You got to be, I don't know if you get certified, whatever. At any rate, thank God for the internet. So I got my regulator. There it is. And here's another one. That one happens to be 3/4 inch pipe thread, you know, and that one's 1/2 inch, which just bolted up to everything that was already existing here. Um, then we got our little high pressure regulator there. I do have a big one of those, similar to the green thing, but it's red because it's high pressure. So that'd be the first stage regulator. That's on the way. So the final configuration of this thing, will be legit. It'll be like a professional had done it. I'm kind of fumbling my way through it here, but whatever. That's how some people learn. Big deal. So I hooked this thing all up and we did a load test, and it did function correctly. It ran good for about a minute. And then as I'm walking away here, walking through there was no mud. We had a downpour last night, but I hear the transfer switch go bang back to primary source. It had been on alternate. I threw the breaker. We did a load test for real. The generator accepted the UPSs accepted the power from the generator. The generator took the load. It was sucking down the fuel just fine. And I'm like, yeah. And then, I start walking away, all triumphant and everything, and pow! I hear this big, bang. I had my earmuffs on, but I still could hear it. And that was the transfer switch going backwards, going back to primary. So the brain box saw something it didn't like. So that's why this is kind of all apart. This rat's nest of bullshit in here. So what I found, doing a very close inspection here, was that red thing right there. That's a varistor, or whatever the hell. Variable resistor? I don't know. Some electronical bullshit. Anyway, you see that glob of solder on there? That was actually broke. And I can't tell if the lighting's any good for you. Let me try a different angle here. Right in there. That was broke. And I said, you know what? I bet you that's not supposed to be broke. So I had put the meter on the connections here, both here and in the transfer switch, and I had like 5 volts. And I'm like, uh-oh, we have an excitation problem. So that's when I tore into this thing. What I think happened here is whoever set this up and put these big long terminals on here, they basically touched down on that thing and like rubbed on it, and it eventually snapped where that solder is, and it was scorched a little bit, and I was like, that sucks. Because what's happening here is we have these giant capacitors in there. There's 2 capacitors, one on each side of the alternator. 120 and 120 gives you 240. And then these varistors act as a modulator of over voltage and under voltage. They prevent it from running away. So these capacitors kind of create a resonant harmonic vibration inside the winding, and that's where you get your excitation field from. And then those varistors kind of modulate it. So if the varistor breaks and there's no modulation, this thing can run away, either under voltage or over voltage or somewhere in between. So I'm pretty sure the winding is still good, because it's still making like 5 volts AC when it runs. And no magic smoke came out or anything, so that's a good sign. However, I pulled out the capacitors here, and you'll notice that it's a 35 microfarad. That's the rating on this Jimmer Jammer. So I took out the multimeter, set it to, microfarad, and read one of them. One of them was like 0, and the other one was like, 4 point something. And they kind of are discolored on the inside there. I don't know if you can see that. Let me see if I can, get the lighting a little better for you. At any rate, you see how it's like half and half? It looks like, a yin yang or something. I'm pretty sure this thing's shot. It's toast. And again, nobody local has these things. Maybe they do, maybe they don't, I don't know. But it's like they don't want to talk to you. Whatever. So I found them on eBay. They got to come from freaking Texas. Each one of them was like $16. So to do retard troubleshooting and just replace the thing, put it all back together, and turn it on and see if it works. And if it does, hooray! If not, then whatever. I don't know. For $30, I'm like, yeah, that's a no-brainer. So that's where we're at with this thing. And it did get rained on too. I don't know if that had something to do with it, because we're not exactly watertight here. But maybe I'll throw a tarp over it at some point. I don't think that had anything to do with what was going on in there, because that one varistor was actually broke. And then the other thing that was puzzling me about these is it says 50 hertz. I mean, here in America, we don't do communist hertzes. We do 60 hertzes. So the ones that I ordered are 50/60. So I don't know if they had something to do with it. This backwards dumbass capacitor, it wasn't going fast enough, apparently. It was just slightly slow. All right, so that's enough of that. So hopefully we get this thing up and running. There's a dude local on Facebook that's got another type of generator, a little different configuration, but I'm almost tempted to get it just so that I have this thing up and running and can actually put the transfer switch in auto and send it, so that if we do get a power outage or something, I'm protected. All right, on to the next thing. So the 3 wires here going up to the chicken coop. They eventually have to tie into that hot block there. That's hot now, so if I touch it, I die. So I'm going to try not to do that. So we got to make a connection into that, but it can't be a completely live connection, because if we energize these 3 wires constantly by landing them right there, because that's hot right now, because the supply from the main panel is coming in, and then it goes, yeah. What is happening here? Oh, yeah. So the supply from the main panel is coming into there where it says preferred, and then it's going through there, and it comes out L3, L7 where it says load, and then it goes into that, and then from that it goes into the sub panel on the other side of the wall here. Yeah. I haven't been, doing like 50-hour weeks or nothing. All hours of the night, 3 a.m. cutovers. Gotta love it. So anyways, if we were to just land these right there, it'd be energized right that very second, and then the transfer switch that's up in the chicken coop would immediately go to the generator source instead of the primary source, and it would just stay stuck there. So that's not what we want. So we got us here a 50 amp rated contactor. So basically, you see in the center there, that kind of moves up and down because there's a coil inside there, and when you apply 120 volts here on those 2 posts, it activates the coil, closes this, we'll call it a relay for lack of a better term, relay contactor dealio, and then power comes in here and then will eventually come out the other end. So I got to just put them connectors on there. So I got to take these connectors and crimp them onto there, so that I can land them on this thing. So then this, I got to be real careful here because we got metal. If I drop this like a dumbass and it sparks, it's gonna suck. So I gotta find a home for this somewhere in here, somewhere in that area. I'm gonna disconnect that neutral and move it over one, so that when I'm coming out of the bottom of this thing, I can kind of land it, and then everything will be very nice and neaty. Yeah, I just made that up, neaty. Nice and neat. You know, and then these wires here will come down and onto the other side of it. And then we got our 2 terminals here that's going to come up there and touch those relays. So I've started to build out the wiring and the circuitry or whatever for the kill line, and also for the activation of the backup line to the chicken coop. That there is a time delay relay. I don't know if we can activate that or not. Just so you can see the countdown. I don't wonder what's going on here. If I flip this thing to manual, will it? You know, I don't even know if I dare even freaking touch any of this stuff while it's all apart. Oh, I know why that ain't working, because I disconnected the red wire. So the red wire is supposed to touch in there and then go down that white wire. I had disconnected that the other day when I was troubleshooting because it was just constantly on. Basically, it's right there in the floor. So this terminal, it's hard to see, but if I get that connected there, get in there. So that's a 12 volt live when our fuel solenoid is activated. So this should be technically hot now with 12 volts. So let me touch it to this white wire. No dice. Well, I don't know. That worked the other day. But like I said, I got some stuff all apart here, and maybe that battery died. Who knows? I don't know. At any rate, let's just connect this, because something is not. Actually, let me set that back to manual. Connect that up again. Did we get Sparky or anything? No. All right, never mind. So trust me, when come on. Yeah, there. All right. Yeah, when that gets 12 volt, it comes in there to that distribution, then this thing turns on. And this is user configurable. So these little switchies here, you can set this to do different behaviors. I have it set so that as soon as power is applied here on the voltage in, it boots up and it immediately starts counting down from 45 seconds. And you can tell it the time limit. I just started at 45 because it seemed like a good starting point. But the idea being that when the fuel solenoid kicks on, this generator turns on, you know, we're going to start counting as soon as that happens. 45 seconds later, this thing should be plenty warmed up and happy. And at some point, the transfer switch will have thrown either before or after, but that was going to time down. And when it hits 0, it's going to turn on the relay, and then it would apply power to our contactor and then send power up to the chicken coop. That was the first version of that. The other idea here, and this is something that I have, I had in the back of my mind originally, but didn't really think I would bother with it. These 2 wires here, this white and the black, this is actually 120 volts right off of the winding. So there's our white and black wire right there. And that was powering that fan. So this is a cooling fan for the whole thing when it's, running. And this motor is like, 0.35 amps. Well, at 120, it's 0.34. So 0.34 amps of 120 was what that fan was drawing directly off the winding. Now, something that I know, in the back of my mind is that, it's not a good idea to start a generator under load. So you can't really have a whole lot of load on it when it actually fires up, because you'll get a field collapse and it won't actually start, it won't actually generate power, and or you blow things up in the, voltage regulation side of the house. But 0.35 amps coming out of this 120 line here, that's 120. And it don't take no, huge amount of voltage to throw those little relays. I don't know if I would send 120 from the generator right at this thing. I don't know what this is rated at. Does it tell us? It tells us how much, horsepower and amperage and load that it will handle on the contactor, but I don't know exactly what the coil on the inside of that thing is rated at. At any rate, so I remember I was puzzled at one point whether or not I had a source of instant on power from the generator. So I sort of have found two different ways to do that. I found the 12 volts. I have tested that out. I mean, this thing did run. I mean, trust me. So I have 12 volts coming out of there, and I've also got 120 volts coming out of there, out of this particular generator. So either way, I've got an instant power source that I can use to kind of control my logic here. So I'm kind of on the fence as if I'm going to still use that time delay relay or just feed it hot right off of the 120 coming out of the generator. The other thing that I've got going on here is this green wire, or this green extension cord that kind of goes back through and actually lands this one. It lands there. The yellow cord is the kill line. So all these orange blocks throughout all my panels from here all the way up to the chicken coop, that's the kill line. And it's orange so that we know that. And basically I'm pretty sure that orange is voltage from another location coming into a panel, for like some sort of standardized color code. But the green, so this green line is actually 120 volts from the UPS. So the network UPS is in there. So this is, 120 from there. And that's what I was planning to use in order to activate this and a couple of these jobbers. So this is an 80 amp relay. It's rated at 80 amps. And this is what I'm going to use to interrupt power to the air compressor, as well as the water heater up top. Coil is AC 110. So it's a 110, 120 volts. So the power that's coming out of the UPS would be able to hit this and, activate the relay. And, hopefully, actually, this is the better one to show you. This is actually a 12 volt coil, which I had purchased prior to deciding that I was going to use 120. But you can see that this is our supply side where these copper wires are. And then we go up into the flicker, or the actuator, or whatever you want to call it. That round thing in the center there is the coil. When that energizes, it pulls down on the flicker. And then it goes from normally closed to the normally open contact. Problem with this, and I didn't really realize this when I bought them, but it's kind of a deal breaker for what I got going on here, at least in the transfer switch enclosure, is the normally open side is coming, or the normally open contact position is actually coming off the side. So the wires would have to like come out and around. So I would have my feed coming in, and then I'd have wires coming out and around. And, I was kind of eyeballing this thing in here, trying to figure out where it would go. And I was not in love with the way the wires would have to be routed in order to use this particular relay. It sucked. So that's, I guess, a third item that sucks. So, because our feed comes in where these copper wires are, and then it would sit there, and then you'll notice the text is upside down, and that was just stupid. And then I'd have to come out the sides. So then I'd have to come out this way, and then I'd have to come out this way, and then come back around and go up, and I'm just like, you know what, that is stupid. I hate it. I'm not doing it. That's when I found this guy here, this Eaton 50 amp contactor, which is, super industrial quality, made in, well, I mean, it's probably made in China, but you know, the intellectual property came from America, right? So yeah, made in China. I mean, they're both made in China, but you know, that's like better made in China. And this is available all day long. Like you go search that part number, bang, you got another one, and it's like, you know, commercial / industrial quality. And plus, my wires are straight up and straight down. It's a lot cleaner. It's a lot more straightforward. That's what I'm using. But I forget where I was going with this exactly. But you know, when I do the air compressor and the water heater, these are going to be in their own enclosure, and the enclosure will just be sized appropriately in order to accommodate this and, you know, all the stuff that's going on in there. Plus, it's a DIN rail. So yeah. Yeah, so a lot of high-speed rambling here, but that's just the way it is today. Yeah, so I've not given hope up on this guy yet, but I'm starting to see what people were talking about where, you know, this enclosure on the top of the alternator just shakes itself apart and kills itself. So I'm not very happy with that. We got to fix that. I don't know how exactly. Well, I mean, I got a kind of an idea in my head, but I'm probably going to end up making another one of these covers, like this part here. This, you know, part that's bent at a right angle. I'm just going to bend some metal on the metal brake and make one of these covers just to close this thing up. And then where these two knockouts are already knocked out, I'm going to come out of there into another better enclosure out, you know, in front of you in the generator shed. But we have to, you know, kind of reuse all this stuff, especially the breaker. The breaker needs to be used because it's got the ground going through it, so that when the breaker flips, it kills the ground to the system, and then the actual engine will shut down because the ground went away for the fuel solenoids and everything. You know, that's pretty slick. So I am hoping that it's just the two capacitors done shit the bed, and that's why it stopped making electricity. And that when those two additional capacitors show up, I'm just going to put them in there and put this all back together and cross the fingies and light her up and see what happens. And then hopefully we get some electricity, and then I'll have a legit, you know, video of the thing running, you know, under load for you to, you know, marvel at. So yeah, that's where we is for now. Sorry it's been 2 weeks, but you know, I was waiting on material. I literally watched that propane regulator bounce back and forth between Georgia and Florida for a week straight. I was ready. Yeah, anyway, I'm not a fan of what the North did to the South, but I was ready to go back down there and tell them about my displeasure in this one instance. But yeah, I mean, but we'll blame that on the USPS, which is basically an extension of the Northern thing. Anywho, got my regulator. Take that, New York. Yeah, I got another better one of them coming. Yeah. Where there's a will, there's a way. So a little bit of a delay here, but we're getting there. Once hopefully I get these things back in there, you know, brand new ones, and it starts, you know, spitting out angry pixies, then we're ready to just tear into that thing and redo that, and then it's going to be time to go into the actual generator shed here and start figuring out our stuff up top. Oh yeah, so I went in here and I did a little bit of rewiring. As you can see, this actually looks different from the last time you were here. So let me explain what's going on here. I moved some of this cable management around to, you know, make it easier for things to fit. And I found circuit breakers. And that reminds me, I need to yell at the dude that I bought. So these are 10 amp rated. So this right here is the AC voltage that's coming off of the UPS behind me. And so if I go boop, see that shuts down. So that is UPS voltage right there, and that's coming out of there. This is then going here, there, and everywhere. And what is the deal here? Oh yeah, so this relay over here is coming out of there, and then this down here is coming out of there. I ran out of these red connectors, these red bridge connectors, you know, bridge together these DIN connecty things, the DIN rail terminals. So these outer terminals, this one here and this one on the end here, that is actually the kill line. So the kill line, or I'm sorry, Jesus. That's the UPS power line. So the UPS power line is coming in here, and that's where it's fed out of. So I have a 10 amp breaker. The UPS itself has a 15 amp breaker, you know, where the thing plugs in. So this cord plugs in right here. I'm actually going to redo that. I like the Harbor Freight connectors that have the light in them. They got the little LED light to tell you that it's on and hot. I like those, so I'm going to add that on there. So UPS itself has a 15 amp breaker, but you know, when that pops, it brings down all three outlets in the gang of outlets that's on the back of it. It wouldn't kill the network because the network is on the separate 20 amp outlet on the back of the unit, but I just wanted to put a breaker in here so that I have a way to de-energize right here locally without having to, like, you know, go behind me and undo the power cable, you know, where it plugs into the UPS. So basically the kill line and then all this other jimmer jammer stuff in here is protected by a 10 amp breaker, which, you know, for 16 gauge wire, because that's what these extension cords are. This yellow cable goes up and all the way up to the chicken coop. You know, it will be live once they get bridged. This guy here that's hanging, this is going to come over and down in conduit. I'm going to cut into here and put a box, and that's where our interrupter relay is going to go. And then this 120 extension cable here, that is our 120 volt kill line. That's what's going to fire that relay to turn off the air compressor when the generator is running, so that we don't overload the little generator. So that's what's going on in here. That was our quick segue. Segues, gotta love them. All right. So then over here on this side of the generator shed, that's going to get out of here soon. So I'm going to cut into that and move that. That's actually going to go up the hill. So it's still going to be part of this water system for like crop irrigation and stuff, but just not down in here. All right. I found some terminal blocks, big heavy duty, like 175 amp rated terminal blocks that I'm going to use to join all these together in there. So it's going to screw into the back, and then these are going to go in there, you know, big heavy duty connectors, so that'll be done properly. When the generator feed line comes in, you know, that's that big cable outside. When that comes in here, that's also going to land on a terminal block, because somewhere in here I'm going to have to do a flexible cable into the power distribution box where the generator is going to be somewhere up in here. The other thing is I'm going to have to undo that muffler for the diesel. Undo that muffler, cut a hole in that wall, send the muffler that way. And then the gas jobby is going to be suspended in this area. And that's where we got to figure out where we're going to have to weld in some additional strut. And you're probably wondering, how the hell is he going to get the generator up in the air to suspend from this strut? Well, I got me a plan. What I'm going to do is, let me get you lined up here. That rib in the ceiling there, where it's, you know, it's pushed up higher, so from our point of view, it's recessed. In other words, the center one. So you got the two struts, the two things that are lower, and then the one in the center. In that center thing, I am going to weld in a barn door track, a sliding barn door track, because you got the hangers that slide in that rail and that track to hang the barn door from, and that's, like when you move the barn door back and forth, that's how it slides. So all that stuff's designed to carry quite a bit of weight, because like my barn doors, they're hundreds of pounds on the front of the pole barn here. So that is exactly what I need to, lift up and slide into place the generator. So the slidey part, I'm going to attach a pulley or a chain fall or something. And basically, I'll be able to forklift the generator right into this area here and then just kick it. Big bam, kick it into this corner, and then drop down my winch, and then winch it up, and then just turn it, and then get it up and then slide it down the rail, and then get it in place where it needs to be, and then we'll install all of our threaded rod and strut, and get that all nice and happy. That's how I'm anticipating that to go at this point. And then, we got to cut holes in there for ventilation, for fans, and, I'm probably going to cut this out here, replace that with a louver with some fine mesh like you see it here already. Replace that with a louver vent so that it'll open up when the fan kicks on to keep the little propane guy cool. And then down here somewhere I'm going to have a battery thing. I'm probably going to build a shelf in that corner and put the battery for the diesel and the battery for the propane in there with float chargers. So I'm gonna have to run another circuit over here so that the float chargers plug in close by. Yeah, so that's kind of where I anticipate all this going. The other things I'm kind of contemplating are, I need to kind of plan out in my head where exactly the muffler for the diesel is going to go, because I don't want it to crowd the propane generator, and I don't want it to be in the way of servicing the propane generator or getting really hot, next to components that it shouldn't get hot to. The other thing we got to consider here is where we're going to bring our fuel line in, the propane line for the. Oh, that's a mosquito. That's the first live mosquito I've seen this year in 2025, New York State. Yeah, I didn't get him. He probably knows I don't want him here anymore. At any rate, so probably up above these water lines is where I anticipate running the fuel, the propane line. I'm trying to. I got to see what code actually says for what it has to be, whether it has to be black iron pipe, or if I can use that new confangled flexi stuff they sell at Lowe's, and just strap it in really good. But that's probably going to come along the top there, and then hop over in a rubber hose, and with a shutoff valve and everything the way it's supposed to be, all legit and all that. And I got to figure out what to do with this muffler. So maybe I cut the flex pipe like right there, send it out that way, or maybe I have to cut it right there and then just use one of the mounts for the propane generator, just really extend that rod all the way down and then just have it go out the wall as it is. Because the other thing I got to account for is the distance of the muffler itself. Where it comes out of the manifold and comes up, I think it's too long. It's probably going to impact the wall long before, So I may have to, just drop the whole thing down lower to about here and just send it across the way it is. So basically, I just need to concern myself with, like when I come back in here, I'm not going to have to do any maintenance or anything. Because the oil filter is right there, the dipstick is right there, the starter, the fuel pump, basically, all the important shit that you got to work on for this thing is like right here. So I need to be able to like stand or crouch or something right in here. Plus the batteries are going to be in this corner. So I probably, don't want to go any lower than this or whatever. We'll have to figure it out. But it just all needs to line up. Everything needs to kind of play nice with each other and that sort of stuff. Yeah, so that's kind of where we're at right now. And yeah, it's not rambling. So like this here, this is a plastic box. I don't know if I'm gonna keep this long term or not. I may redo this with a steel box, larger, so that I can. Maybe not. Maybe I mean it's the same size. I mean everything's in there. Oh, I can't show you because you got to literally unscrew it. But something similar to this is going to be right in this area here for the propane generator. So like all those controls from the propane generator, plus I'm going to buy some gauges for different things, like amp, voltage, and frequency and all that stuff, so that you can look at it real quick. I don't know if I'm going to go analog or digital, but I'm going to have another box, very similar idea. I'll come off with strut and then mount it, nice hard, hard mount. I need to replace this piece of strut, both top and bottom, to actually come over here and grab the other side. So far it has never fallen apart, but it's something that I gotta fix. I'm meaning to do that. Yeah. This thing happy? Yeah, it's happy. I did have an O-ring go, that broke on the top of the fuel filter, and it was leaking fuel at one point and sucking air in, but I replaced the O-ring, and then this thing is just running flawless. The other thing that I've thought about doing is just getting rid of that whole filter body, because it takes like weird freaking filters that you gotta like custom order, and finding a filter adapter that takes just like regular off-the-shelf like Cat or Napa filters, and then just buy like 10 of them, because that's the original filter that came with this unit, and this unit literally has 133 hours of runtime on it. I kid you not. That's part of the reason why I bought this, even when it had the toasted alternator on the back, the original Stanford alternator. I mean, you can see there's still paint on the exhaust manifold. So, I mean, this is basically a brand new engine. Yeah, so that's the update for now. Sorry I don't really have any, more cool stuff to, check out, or, big milestones, but we kind of ran into some unforeseen obstacles. The generator was working just fine. It made power. Everything was happy. The UPSs weren't complaining or anything. And I was literally walking back to my office to hop on Home Assistant and to go into the UPS management pages to see exactly what the frequency and the output power was and all that stuff. And that's when I heard the transfer switch go back the other way, and I was like, "Some bitch." So it's a setback, but hopefully, it's just the capacitors that went bad and nothing else, and I can get that thing back up and running, by next weekend, and hopefully have a even better video for you at that point. And then, because once that is running, I will also have the magnetic contactor installed for the coupe backup line, and plus I'll have it terminated up in the coupe, in the transfer switch up there. So we'll be able to do an actual live test of both the generator and the whole, transfer switch up in the coupe to, put the coupe on backup power. So that's where we're at. So hope you enjoyed this little update. Sorry, like I said, it's not, bigger things to chew on, but every now and then all we get is crumbs, unfortunately. So it's Thursday. Have a good Friday, good weekend, and take care. Catch you later. Bye.